Hello everyone. So this is a video from section 8.1 Law of Sines for the Pre-Calculus course. The question we are looking at is the following. Find all possible triangles having the given measurements. So part 1 says angle A is 45 degrees, angle B 70 degrees, and side C has 11 units. And part 2 is angle B is 70 degrees, angle C 65 degrees, and side C 11. So we start by doing the first one. Now, first of all, what do we mean by find all possible triangles? We are trying to find all the possible measurements for the triangle having these three values for angle A, angle B, and side C. Now, drawing a figure is always helpful. So let's begin by getting a rough figure to see what are the given measurements. So we have A, B, C. Angle A is given as 45 degrees, angle B 70 degrees, and the side opposite to angle C, little c, given by 11 units. So we are given angle, side, angle. We are in an ASA situation here. To figure out the remaining measurements, what we first see is what is given to us. To use law of sines, so let's recall what law of sines says. So law of sines is given by sine of angle A by little a equals sine of angle B by the opposite side equals sine of angle C by the opposite side. So we are given 3 out of these measurements. We need to figure out the remaining 3. For that, we need at least one of these fractions to be completely given to us so that we can use that to solve for the remaining. One of these fractions, meaning we're looking for pairs of opposites, angle A and side A, or angle B and side B, or angle C and side C. Now, in this particular question, if you notice, we do not have any pair of opposites completely given. So what can we do to figure out this? So side C is the only one given to us. So let's try to solve for angle C so that we'll have those two things given to us that will complete one pair here. So angle C, as you know, using the angle sum properties for triangles, it's 180 degrees minus angle A plus angle B. So this is going to be 180 minus 45 plus 70. So this ends up being 65 degrees. So now that we have found out angle C, let's label it with a different color because we solved for it. So angle C, 65 degrees. Now we have this pair. So we can complete this last fraction over here. Now, proceeding with that, sine angle C by little c. So choose whichever alphabet you prefer. For instance, let's try to solve for little a first. So sine of angle A by little a. Now from here, what do we get? Plug in the given values. So this is going to be sine of 65 degrees over little c, which is 11 units, is equal to sine of angle A, which is 45 degrees, divided by little a. Plug into a calculator and get the values for sine of 65 degrees, sine of 45 degrees. Please make sure that your calculator is in degree mode and not in radian mode when you're doing this problem, because the measurements are given in degrees here. Now finally, rearrange and solve for your little a. So from here, we would end up getting that our little a is going to be sine 45 degrees multiplied with 11 by sine 65 degrees. Now going into the calculator this approximates as 8.582. So we have figured out side A. Now the last thing left to do is to figure out side B. So use the same thing, law of sines, to get side B. Again, we are using sine of angle C by little c equals sine of angle B by little b. And this ends up being sine 65 degrees by 11 equals sine of 70 degrees by little b. Just like solving for little a, we solve for little b, and that ends up being approximately 11.405. Now, we have figured out all possible measurements here. How do we know if there is another triangle or not for the same given angle A, angle B, and C? So remember, by the ASA congruence rule for triangles, you can only have one possible triangle that has the given angle, side, angle measurement. So we have found out all the possible triangles here, and hence what we can conclude here by ASA congruence, this is the only possible triangle. And hence we have completed part 1 of this problem. Okay, so here is the table of values. So angle A is 45 degrees, angle B 70 degrees, and angle C we found out is 65 degrees. Side A 11.405, side B is 8.582, and side C, which was given to us, is 11 units. Let's have that there for part 1. Now for part 2, let's see what the situation is. So if you draw a triangle and label these measurements, so let's again have triangle ABC. Angle B is given as 70 degrees, angle C is 65 degrees. Side opposite to that is little c, which is 11 measurement. So now, what do we see here? We are given angle, angle, side. We are in an AAS situation. So we are actually fortunate in this case, because if you want to use law of sines, we needed a pair of opposites given to us, and we are already given that here. We have angle C and side C already given to us. So basically, part 1 has the same measurements, if you notice, for angle B, angle C, and side C. So our work pretty much follows the same pattern. You start with law of sines, and sine of angle C by little c, this is given to us. So you plug those values in, and first we will solve for little b using angle B's measurement, and then you go back and use angle sum property of triangles to get your little a over here. If you solve, that is ending up as 45 degrees. So just complete side A also using that measurement. And by the AAS congruence rule, you just have one possible triangle. So overall, both these parts are giving us the same triangle with the same table of measurements. Thank you.